All right, good day, everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presenter today is Warner Chaves, and his presentation is Cosmos DB, Geo-Replication, True Global Database. Before we get into the presentation, I do have a few announcements, so I'm just going to go through those right now. So the first thing is that if you are not getting our virtual group newsletter, I do recommend that you go out to cloud.pass.org and subscribe. You'll have to log in first to subscribe, and it's just your pass login to get logged in, but the benefit of subscribing is that you'll get the newsletter that I send out approximately every Monday. That's got a list of the 2 presentations for the coming week and a list of all the other ones coming up included in it, and that way if there's any scheduling changes like we had a little bit in July, you'll get made aware of those prior to logging in and finding out that something got rescheduled. Speaking of upcoming sessions, I do have a number of sessions. I have one more that I need to get added in here, but we've got sessions pretty much twice a week through the middle of October. I've got one more to add in. The 3 on the screen that are in orange there, those are the ones that we just added in this past week. So there are new presentations coming all the time. If you are interested in presenting, you can just email us. Just email cloud@pass.org. And doing so, we'll get that email into my inbox. I'll take a look at it, get you scheduled up, communicate and figure out a time, and we'll get you on the calendar. If you don't want to do an email to start with and you just want to fill in the form, we do have a form that allows you to put in all the details, and then we can get scheduled from that perspective. Coming this fall is the PASS Summit. It's 2019's version of the PASS Summit, and we've got over 200 sessions or PASS has over 200 sessions that have been scheduled for the summit already from the community of speakers. If you are planning to register and have not yet registered, you can get a discount code by just going out to your registration and adding into that at the promo code area, the VGDIS FKDQ, and that'll get you $150 off your registration. If you are interested in additional online learning, there are a number of other virtual groups like this. Some are focused on language, such as Global Spanish and Global Chinese, and others are focused on different job roles and technologies like application development and virtualization. Those virtual groups have sessions coming up all the time, so I encourage you to go out and take a look at those. If you have questions throughout this session, please go ahead and type them into the question panel, and then at the end of the session, we'll go through those questions, and time permitting, we'll get them answered. All right, those are the announcements that I have for today, and at this point, I'm going to hand things over to Warner for his presentation today, Cosmos DB, Geo-Replication, True Global Database.
All right, sounds good. Thank you, Jason. So let me show my screen here.
You're welcome.
And
that's coming through great, so I'm going to mute myself now.
All right, and let's get it started. So thank you, everybody, for joining today and this afternoon, morning, or night, wherever you are in the world. This is Cosmos DB Multi-Master True Global Database, and my name is Warner Chaves. I'm SQL MCM and Data Platform MVP for Microsoft as well. So a little bit more about me. I've been working in the industry on data platform solutions for 12 years now. I used to work out of HP in Costa Rica, but I work now for Pythian out of Ottawa, Ontario in Canada. And if you want to reach out to me, you have my contact info there, my blog, my email, my Twitter handle, my LinkedIn, and also the company that I work for, Pythian. We have a bunch of other technical content in our blog, not just related to Microsoft, but to other companies and other cloud platforms as well. All right. So the agenda for today, we're going to go over the multi-master replication capabilities of Cosmos DB, but not just multi-master. We're really going to go into the general replication capabilities of Cosmos DB, what it can do, what are some of the things that you need to think about, how Microsoft has implemented it under the covers as much as they have disclosed to the public, and do some demos, show you guys the difference between, placing your data close to your clients, how to do the multi-master config, which is very simple. We'll go over just the portal experience and more things, okay? So we're going to cover some quick fundamentals of Cosmos DB. This is not 100% intro session of Cosmos DB and how it works. That's really not the purpose here. The purpose is to focus on the geo-replication capabilities, okay? So, but, you know, we're going to go through just some of the basic fundamental concepts. We're going to talk about the consistency model just because, again, it's one of those things that really differentiates Cosmos DB, and it's usually something that is interesting and important to understand in context with mixing with the replication, especially across large distances. We're going to obviously talk about the multi-master replication, the conflict resolution methods that you can use, and we're going to do some demos of the whole thing, all right? And really the scope to understand these replication capabilities and multi-master capabilities and conflict resolution capabilities is to have some database knowledge, because we're going to go into the basic differences between Cosmos and relational databases in terms of NoSQL capabilities. And we're also going to cover how Microsoft has implemented some of these things architecturally. So as long as you know how databases work for the most part, you're going to be just fine following along, okay? So first, before we go into the actual technical piece, I wanted just to introduce some of the Cosmos DB solutions that Microsoft showcases in their promotional materials. So the next few slides, I did not make them. I just pulled them from the Microsoft Cosmos DB promo material that we get as MVPs, because I really want to show people, before we talk about the technical parts, I want to show people the kind of things that this is being used to build, to get you an idea of scope, what it can be done, why are people choosing it, right? So for example, Microsoft has these use cases or case studies about Cosmos DB that, like I said, I just took them from their showcase slide deck. And if you can see, for example, we have here Domino's Pizza being used for the order experience through the browser using Traffic Manager, using multiple Cosmos DBs around the world. So we're going to see some things here that are common between all of these different solutions, right? They are pretty large. They have many users, and you can see most of them are globally distributed, right? So for example, the next one that they have is Toyota with IoT telemetrics that feed car sensor data into IoT hubs that then can be moved into Azure to do big data analytics. They can be queried operationally through Cosmos DB, and then they can do all sorts of other things reporting around them, right? So again, what is some of the common themes here? Obviously, lots of cars, lots of data, global presence of the company into what they are trying to do, right? Same thing here with the app for Real Madrid, which obviously some of you, if you are soccer fans, then doesn't need any introduction. If you're not, then just to know, it's probably one of the, I don't want to offend anybody that's not a fan of Real Madrid if I say it's the biggest club in the world. So we're just going to say it's one of the biggest soccer clubs in the world, right? So 450 million global supporters that have signed up as part of their fan club. They want to serve them with a personalized experience through an app or through their browser, and they use Cosmos DB for help with that, to try to guide the digital interaction. So that means, suggesting content, making sure that they see their most relevant articles, and so on. Jet.com. So again, it's about doing real-time processing of data, low latency for processing, inventory updates, same thing, multiple regions around the world. So we keep seeing those common elements, right? And then one that is very common right now is the whole app development for gaming use case. I think is a really good use case for Cosmos DB, because we have seen, and probably some of you guys remember, kind of like viral phenomenons in terms of app stores and app games like Angry Birds or Candy Crush or all those games. If they catch on fire with their audience, then they go global pretty fast, and then suddenly everybody's playing it. Kind of like what happened with Pokemon Go as well, right? And in those scenarios, well, you want to be able to serve your users from all over the world, give them a good low latency experience, and be able to use a platform that is really geared towards that type of experience, right? All right, So with that said, and hopefully that sets the stage to pique the people's curiosity about like, well, maybe I should learn a little bit about Cosmos DB. It sounds like it's a pretty interesting product. People are building big solutions with scale that we have never seen before. Well, then, you know, we're in the good spot. So some of the fundamentals is that Cosmos DB is a NoSQL / new SQL database, because I mean it does use the SQL language if you're using the document / SQL API. So it's not really NoSQL, it's more new SQL, which is another term that's being used around nowadays. You might see some people bring it up when they're talking about new products such as Microsoft's Cosmos DB or Google's Cloud Spanner, for example. People don't really use the term NoSQL for those. We use the term new SQL as well, right? But regardless, the big difference, of course, with NoSQL scale-out is that usually when data is ingested, the database gets partitioned by hashing keys. So for example, you have a field that you say the database is going to be partitioned by a specific field. That field gets hashed by the database, and then that determines where your data eventually sits, right? These are all distributed databases, multiple nodes. So your data is not just in one place, like if, say, you have one massive SQL Server data warehouse, right? Another big characteristic of NoSQL databases is that data consistency can be manipulated. There's usually settings to manipulate it. If you are working with something like a Cassandra, for example, or MongoDB, usually there's a couple of choices about consistency. Strong and eventual are the two extremes, and some of the NoSQL databases, that's all they offer. For example, DynamoDB's Amazon's wide column product as well. That's the same. Cosmos offers a little bit more in terms of the choices for consistency, and we're going to go into detail on that a little bit later into what are those other type of consistency models that you can use with Cosmos. Okay. So we have multiple nodes, and they are all talking to each other, and they are all receiving read and write. This is obviously simplified for now. Just keep in mind, you know, this is the general idea that we have many nodes all communicating with each other, and they're reading and writing at the same time, right? So it's not like a SQL Server where, let's say, even if you were to have multiple SQL Server nodes in, for example, an availability groups configuration, you would still just have one node that is read-write, and all the other ones would be read-only, right? That's not the case here. And this, like I said, this is the simplified diagram. We're going to go into the detailed architecture diagrams in a little bit further into the presentation, okay? Something else that's different about Cosmos, just to keep in mind, is that it offers multiple APIs, okay? So you don't just communicate to Cosmos in one way. For example, SQL, obviously, you communicate through T-SQL, right? So Cosmos DB, for example, offers the document database type of API, which is a SQL API, so you can do select queries on it. And it uses JavaScript for modules, modules being store procedures, triggers, functions, right? So that's one way. Cosmos also offers a MongoDB compatibility API. The way this works is that if you have a MongoDB database, then you can connect it to Cosmos using an endpoint that the MongoDB driver thinks is talking to a MongoDB cluster, but it's actually just talking to Cosmos. There's a key value API, so this is a very simple API. You just give it an ID, and then it gives you whatever the payload is. This actually replaced what used to be known as Azure Table. I don't really know why they called it Azure Table when it started, to be honest, because it's always been key value. But regardless, so that's the Azure Table that has now been replaced by the Cosmos Key Value API. There's also a Graph API that's using the Gremlin language. That's part of an Apache project called Tinkerpop to create tools for graph databases. There's also a wide column database mode, which is basically the Cassandra API. So if you like using Cassandra tools, or if you're thinking about a Cassandra migration, then you should explore using the Cassandra API. It works the same as I just mentioned with MongoDB. You basically take a Cassandra tool, and instead of connecting it to a Cassandra cluster, you give it the endpoint from Cosmos, and it doesn't know that it's not talking to a Cassandra cluster. And then finally, the last one they just introduced probably a few months ago It's the etcd API. This is not really a general purpose API at this point. etcd is the metadata store used for Kubernetes. If you are not familiar with Kubernetes, then it's basically a platform for container orchestration and running containers in virtualized infrastructure. It's very, very popular nowadays for running containers. Microsoft is investing on it. It was originally created at Google. So basically, if you want to run a Kubernetes cluster and you want to have your metadata stored outside of the Kubernetes cluster, then you can use Cosmos DB now as well with this etcd API. Okay. Point being is that Cosmos is a database engine that shows different faces depending on what you're trying to do with your application, right? So you can use it with SQL, you can use it as key value, you can use it as graph, you can use it as a wide column, and so on, right? Okay, so to understand here again what we can achieve in terms of scale or in terms of the geo-replication, how we make it really behave like a true global database. So we also have to talk about the concept of a Cosmos container. And when I say container, I don't mean anything like Docker containers or Kubernetes like I just mentioned. That's not what it means by a container, okay? It's a different concept, and I'll explain why it's a container. If you create a collection in Cosmos DB when you're working as a document, then that's a container for your documents, right? But if you're using a graph API, then you're not really creating a collection of documents. You're creating a graph, right? So then your graph is a container, right, for that data. If you're using the key value store, then you're not creating a collection or a graph. You're creating a table, right? That's the concept, the table. And that would be the container for the data, right? So we just use the general term container to just generalize whatever it is that you're using regardless of the API, right? So if you're using the document or the MongoDB API, those are collections. If you're using graph, then it's a graph. If you're using the wide column API or you're using the key value API, then the container is known as a table, okay? So you might see those different terms depending on where the API, which API is being used, but they all boil down to the same thing, right? So the container is where the data is stored, right? Same as like you would have in a relational database, you would have a bunch of tables. Well, in Cosmos DB, you would potentially have a bunch of containers, right? And then each container, you have to provide a key that gets hash partitioned, and then depending on the value of that hash partition, then that data gets divided on several different nodes. And then the system automatically under the covers will make sure that the data is distributed on different nodes, and that if you, let's say, one specific partition starts to get too big and starts to max out the capacity of one node, then automatically under the covers, the Cosmos DB engine that Microsoft has will start moving that data over to another node. And then that way, your database can basically continue to grow without you having to do anything about it. This is all managed by the system, right? So you don't have to worry that one of your nodes from Cosmos is running out of space. Like that's just simply not your responsibility, right? Cosmos is a platform as a service offering from Microsoft. You don't have to worry about the actual underlying nodes or patching them or how many cores they have or anything like that, okay? So the container, like I said, is the entity that holds the atomic records, whatever those may be, documents, graph nodes, or table records, right? So about replication capabilities. So one big difference from Cosmos to some of its competitors, for example, DynamoDB, is that from the very beginning, Cosmos was built with the idea that it was going to be a product that offered really robust and far-reaching replication capabilities, right? It wasn't built into the product after the fact, okay? So it was part of their core design that they wanted to have really good replication capabilities. And it shows because, you know, really quick now, after a few years in the market, now Microsoft has basically enabled Cosmos everywhere in all the regions, and you can do replication between almost every single region. So in the story of the product at the beginning, it was called DocumentDB, if some of you are familiar with it. But then as Microsoft started to expand on the replication capabilities, and they also started to release more APIs, so it wasn't just a document database anymore, then it got rebranded to Cosmos DB, right? So read geo-replication was the first type of feature that was released. So that means that was still single master with multiple read copies. And then multi-master geo-replication is possible now. Right? And this has been GA now for a while, I would say, maybe like a year. It has been allowing multi-master, at least in preview for sure. It's generally available now, fully supported. And then consistency levels that you can pick for your collections, either in single region or multiple region, they go all the way from strong to eventual. And we'll go into detail into what those mean and how does it impact what you can do in terms of geo-replication. Okay. Then the other thing to understand as well that also impacts your replication and impacts your cost is the performance model of Cosmos, right? So like I mentioned before, when you're working with Cosmos DB, you're not provisioning cores or RAM or storage. What you're using is request units per second, and that's the definition of throughput. How much can Cosmos either consume, or how many queries can it actually you can execute against your Cosmos database, okay? Operations that you do, so either inserting a document, updating a document, or querying, consume a deterministic amount of request units, okay? So if inserting a 1K document costs, I don't know, let's say 10 request units, then every time you insert a similar document, it's going to cost roughly the same, right? And if you suddenly insert a document that's double the size, then it's going to cost you about double the cost in request units, right? And that's the amount, the request units are the amount that you provision, okay, for as part of your Cosmos account. Now there's two options for provisioning request units. They are provisioned per container or per database. If you provision it per database, then they are shared by the different containers that you have created inside your database, right? And then request unit consumption is driven by its different factors, right? So I mentioned item size, the document size, for example, is one. The container size, so if the database is the table or the collection or the graph is small or is bigger, right? It makes, if it has more indexes, for example, things like this. Data consistency, so if you want to run a query with strong consistency compared to running it in eventual consistency, there is a difference in cost. Indexing policy, so by default Cosmos DB will index all properties, but you can change that, of course. And if you're indexing less fields, then obviously you'll have cheaper cost in request units because the system is not going to have to update as many objects when you are inserting or updating data, okay? And then query complexity, well, obviously if you are running just a simple select start from, it's a lot cheaper than just running something that has to do a join or something that has to do a group by in a document or anything like that, right? Okay, so let's just jump in here to the geo-replication config. So we'll do a little break here from the slides and just show you guys really easy here on the portal what the geo-replication config looks like. So let me just jump into my VM here. And we can see here, I have a lot of Cosmos DB accounts, of course, so bear with me here. So I have this one, I already pre-selected it before we started. It's just called latency single region. So it's basically a single region Cosmos DB database collection right now. And you can see here, if I want to go back down, and it says replicate data globally, just to show you again how easy the experience is. Currently, this database is sitting in, this is Southeast Asia right now. And if I go here on the side, again, you can see this option here, right, where it says configure the regions. And it says enable multi-region rights, disable or enable, right? It says, so to turn it into a multi-master database, it says easy as just saying, okay, well, I want to enable the multi-region rights. So we can do that if we wanted to. And then, well, maybe we can add a region here. Why not? So let's say we want to do from Southeast Asia to, let's see, somewhere in Europe maybe. UK West, North Europe, UK South, whatever. We'll just pick UK South. And then I want to show you here these, you have these other options, for example, where you can see that, let me zoom in here as well so we can see them up close. All right. So you can see we have the two regions here, and you can say reads enabled, writes enabled, and you can add an availability pair, so saying if you want to fail over to one or the other, or you can just remove the replica from there as well. Something interesting too, if I want to add more than one, I can add more than one if I want to, and then you can just pretty much use all three regions at that point to replicate data between each other. And because I said that multi-region rights are enabled, then I can just write to all three of them, as we're going to see in a later demo, right? I just want to show you guys how easy the actual failover or configuration experience is in terms of allowing the system to replicate data to other places, right? And then obviously if you want to save it, then you can save it at that point. There's no big deal. And then it just goes into updating, and after a little while, then we'll have a link set up there for this particular Cosmos DB database, okay? So pretty straightforward. All right, yeah, whatever. Okay. So let me go back, and we'll go back into our slides. Okay, so let's talk about the consistency models, and then we'll do our first, I'll show you guys our demo here, just to see the impact of the instance on latency. Okay, so let's start first with the consistency dilemma here. So this is also known as the basic question that's covered by the CAP theorem, in case you guys want to dig more into the literature and the academic portion of this problem with distributed systems. But it boils down to this question. Do I want the most truthful data, or do I want the data to be returned as fast as possible, right? So usually, if you are working with a distributed database, there is a trade-off that you have to make to answer that question, right? So why can't we have both? How come I can't have the most truthful data and also be the fastest response? So usually, if you're working in a single data center or they're really close, this is not really a problem because data replicates really fast over small distances. And a database like Cosmos DB can converge in values within milliseconds on a very small distance. The problem is when we start to build systems that are geographically distributed around the planet over long distances. And that's also why I wanted to showcase in the beginning all those solutions, because all those solutions that I mentioned, they are global brands that are trying to reach a global audience, right? And the cool thing about this is that it used to be extremely difficult for just regular people or small and medium business to try to build a global infrastructure, right? You would need to have a global data center presence. You would need to deploy your own NoSQL database with multiple nodes around the world. Make sure that you knew how to distribute them. Make sure that you had strong replication links. All of these things you have to do on your own. And now, as I just showed you in the previous demo, it's just basically a point-and-click experience for anybody in the world with the money to pay for the service to be able to offer a global application experience, right? So that's the really cool part, in my opinion, about this, right? So talking about consistency models, well, on one end, we have a model that offers the most fidelity, but it gives the higher latency, and it has less availability. And that's on the other side, there's less fidelity, but we have lower latency, right? We can replicate faster, and we have more availability, meaning it can sustain the loss of more nodes, right? So strong is the one that will give you the most fidelity, which means I want to read the exact value that it is right now, but obviously gives you higher latency because it has to go always to the source of the data, right? Then Cosmos also offers something called bounded staleness, kind of like what the name says. What you do is you give it a maximum allowed age of the data being stale, right? And that doesn't mean that Cosmos will not do it faster. So for example, I'll show you guys the further along a demo where we're replicating from Japan, and we have set it to a max staleness of 5 minutes. But that doesn't mean that Cosmos is going to take always 5 minutes to replicate the data. Usually it's within seconds. But it gives me the guarantee that it's never going to be over 5 minutes. Okay? Session basically means as long as you are writing and reading on the same session, then you're always going to be able to read your last writes. Okay? Consistent prefix means that there is no guarantee on how old the data is, but you're never going to read data out of order. So for example, if you just had, let's say you were writing some sort of sequence into Cosmos DB, 1, 2, 3. Consistent prefix would guarantee that you were always reading that order, 1, 2, 3, right? It doesn't matter. Maybe the number is already 3 and you're still reading 2, but you would never read something like 3, 1, 2, right? Eventual consistency has basically no guarantees other than if you stop writing or updating a record, then eventually all the nodes will converge to the same value, but it doesn't give you a guarantee of when that will actually be, right? In a system that's 100% eventual, then if, let's say we had a sequence, then there isn't actually no guarantee that maybe you query what the latest number is and you would query and you would get 1, and then maybe you get 3, and then maybe you get 2. So eventual consistency does not respect the actual order that the data was written in, kind of like consistent prefix does, right? That's the biggest difference. Okay. So the good thing about all this is that other than knowing what these different consistency models do, Cosmos DB handles all of this under the covers. You don't have to worry about it. Microsoft has coded all of it, and you just have to specify the consistency model that you want to use. And the actual technical implementation of these different consistency models has already been done, right? So what's important when dealing with a Cosmos DB solution is to select the appropriate consistency model for a particular operation so you get the best performance and cost ratio, right? So if you need something that has to have some guarantee of staleness or has to be strong, well, then maybe you can just do that in strong. But if you can live with session, for example, where you can always read your own writes, then that will be better in terms of performance and in terms of cost compared to the other two, and so on, right? And as a matter of fact, Microsoft says that about 80% of their Cosmos DB clients use session as their consistency model. And something else to keep in mind on how all this plays out in real life is that usually when doing planetary replication over large distances, the latency introduced by the distance between locations is a bigger factor in performance than consistency itself. Meaning I can go all the way to eventual consistency if I want, but if there's still a big geographic distance between my clients and where the database is sitting, then distance is always going to be the biggest factor in the latency. Okay, and this is not just for Cosmos DB, this is for any database system, right? Even if it was a Cassandra cluster, a MongoDB cluster, or any of the competitors in the cloud, they all have the same issue because everybody has to deal with, the limits of the speed of light and noise in fiber optic cables and so on, right? So when the distances start to get bigger, then that becomes the driving factor on the latency, right? So we're going to do a read latency comparison here. I already have a couple of VMs set up. One of them is in East US, and I'm going to have it reading from a database that is sitting in Canada East. So, a big distance, but not around the world. And then we're going to just do a quick other test. That same VM, I'm going to read from a database that is sitting in Japan East. So quite a bigger trip there, right? So let's check it out. So let's see. Go back into my VM, and I have a Cosmos DB client here, and I'm just gonna say status. So I'll show you real quick about how this is. Like I said, this VM right now is in East US, and you guys can see here, I've provided, as part of the connection string, you just have to provide the general global Cosmos DB endpoint, which is this one right here. And I specified that I wanted to use the Canada Central location. So that's what it's being connected right now. Both for read and write, you can see both read and write right now are pointing to Canada Central, right? You can see other things right now. For example, my request units are 400 request units, and my consistency level is bounded staleness, right? So remember, we go strong, bounded staleness, session, consistent prefix, eventual, right? So bounded staleness is pretty close to strong in terms of consistency guarantees, right? Okay, so I'll just do a really quick, I'll do a quick query here. So if I do, this query is just going to query my Cosmos DB collection that I already have in Azure, and it just returns the most recent record for a particular machine, in this case machine ID 1. So this is a record that I wrote earlier today. I actually wrote it from Japan, and you can see what's important here is how long it takes for our client to run that query and get it back, right? So it's 100 milliseconds round trip completely. And I am doing East US to Canada East, right? Okay. And remember, I'm doing consistency as well to be bounded staleness. Now, I'm going to say that I want to do a geo read now instead of a local read, right? So now, if I go to status, and I'm going to zoom in again, you guys can see my read endpoint has changed now, right? And you see my read endpoint is now Japan East, right? It's no longer Canada. And just by obviously querying into Japan, now if I rerun that query, you can see it takes 5 times, almost, yeah, actually a little bit over 5 times the time that it was taking to go from East US to Canada to go from East US to Japan, right? So it's quite a big difference. If you are able to put your clients close to your data, you get a really big improvement in terms of latency without affecting the cost of your solution, other than obviously you have to create more copies, but it doesn't mean that you have to put more power into Japan, right? Even if you had more request units in Japan, it will still not make any difference because the distance itself is the big latency factor. As a matter of fact, I can change my consistency here too to being completely eventual. Okay, and I can just do the status again. And you can see here my consistency level has already been changed to eventual as well. But if I rerun the query itself, I still just get the same type of performance, because at that point the problem is not how fast I can retrieve that data inside the cluster itself in Japan, which is what eventual would help me with. The problem is just simply the time that it takes to move data all the way from Japan into East US where my VM is, right? So again, the client, where the client is and the distance to where the data is becomes the biggest factor in terms of providing a good latency, low latency for a solution that is at the planet global scale, right? And if I go back and just say, no, I don't want to do a geo read all the way to Japan, this is not making much sense because I'm sitting in East US, then I just turn it off. I can rerun the query. And immediately I go back to 91 milliseconds, right? You can see it right here. This is something else that's kind of nice in terms of the developer experience. The Cosmos DB SDK gives you options to do all these things fairly easy and fairly quickly, okay? All right, so that's pretty neat. Let's go back into the demos. And now we're talking about the specific multi-master capabilities. So this is the global topology of a Cosmos DB container, right? So like you see at the top here, it says tables, collections, or graphs. all these things map into the concept there of a container. And then each container writes into these type of clusters of nodes, okay? And then each cluster of node would be a physical partition of the database. And each physical partition might have one or more logical partitions depending on how many keys you have, right? And then you can see here on the corner, each physical partition, again, it's a mini cluster, has three different types of roles. It has a leader, which is the one that receives the data. Then it has two followers, which are used for redundancy and for read-only scalability as well. And if the leader dies, then one of the followers can take its role as well. And then it has another node here called the forwarder that is used only for the replication capabilities, right? That's really interesting. And then we have this other concept here marked in gray called the partition set. The partition set is basically the set of these clusters that communicate with each other across the different regions to maintain themselves in sync. Okay, so if I go back here, we can see here in detail what these partition sets do around the world, right? So for example, the top replica set here, remember that concept, leader, followers, forwarder. Top one is in Europe West, the side one is in US West, and the bottom one is in Australia Southeast. So if US West gets a change, the leader will send it to the forwarder. The forwarder then is the only one that's going to communicate with the leaders in the other regions. And then those leaders will make sure that they propagate that change locally as well, right? And then those leaders also know that this change did not originate in themselves. It was changed by a forwarder, so they don't forward it again and continue kind of like an infinite circle, right? So very neat, very interesting architecture. And obviously we can see here where they are trying to make sure that some of the nodes are not overloaded by having too many roles to fulfill as type of the system, and instead, for example, it created this concept of the forwarder that is just basically focused on maintaining the communication here for the geo-replication. Okay. Something to be aware of in terms of multi-master request units, because it will be a factor into cost as well, is that if you're running a solution that is multiple regions around the world, but you're using a single master, so you're only writing into one of them, then every extra region you have to add 1x more RUs. So for example, if I'm using 400 RUs and I add another node, but it's not a multi-master node, it's just a regular read-only region, sorry, another region, then I'll be using 800 request units, right? Makes sense. If you're using multi-master though, then the total RUs that the container will use is the amount of regions plus 1. Okay, and the additional request units are automatically provisioned because they are used to process possible conflicts and anti-entropy traffic across the regions. Anti-entropy traffic basically means the nodes have to communicate with each other every now and then to figure out where they are in terms of how behind they are from each other. Do they have new data to send? How big is the, if they are behind, then how much is the backlog that they might have to send, and so on, so that it's all optimized and that it's also guaranteed that Microsoft can meet the consistency guarantees that you might have be using in your application, right? So you basically have to pay for 1x extra RUs if you're going to use multi-master, okay, compared to just single master. Single master, you don't have to pay for that extra set of RUs to process conflicts and anti-entropy because it's just read-only copies, so they don't produce any sort of conflicts, or they don't have to keep in track between each other about the differences that they have in their data sets. Okay. All right, so let's do another scenario here. So we're going to run a cross-planet multi-master. In this case, I have two regions, like I mentioned before, Canada Central and Japan East, and they are enabled for writes. I'm going to use VM in East US, and the other VM is in Japan. And the consistency that we're going to be using is bounded staleness. So that's set to 5 minutes. So again, the idea here is the guarantee is that the data will never be older than 5 minutes, but it's usually a lot less than that. Okay, so let's check it out. So I'm going to go back here, and if you guys can see, it says, right now it says that the latest record was from Japan because I was running the test earlier today. So let's reset here something. Let's do a few writes into the Canadian region so we can see the change from when it goes to Canada to Japan. Okay. Cool. This looks like my VM is a little bit frozen right now in terms of connectivity. All right. And it's back to life. Okay. So let me reset this, and we'll just do real quick. One machine, 4 calls per second for 2 seconds, and we'll write here from East US into the Canadian region. Okay, so that's done. And then if I run exec query now, we see the last record that was written is the one that I just wrote, which is, you guys can see M1, machine 1 from Canada, and the current timestamp for right now, right? Okay, so now what I'm going to do is I'm going to switch into Japan, and I'm going to do a write from Japan. So I have the same utility, but this one is on my Japanese VM. So let me run this. So I enter here Japan. And then we're just going to do the same thing. We're going to do, let's say we do one machine. The machine is going to write 4 times per second. And then we're going to do, let's say, 30 seconds. Okay. And then I'm going to start writing. And there, it's already writing from Japan. Now, if you look at the time, it's been, what, a few seconds. And we'll see if we're already getting data from Japan. Yeah, there we go. So you can see the last read I did right before I started Japan, it was M1 Canada. We're already getting records that are originating from Japan that is running right now, right? And if I rerun this, we can see as well here the timestamps are increasing as the changes that are running in the other VM are replicating to Canada, right? So something to keep in mind here, of course, the main thing is it's how simple it is in terms of achieving this. So let me go back to the Japan VM and just show you the snippet of code to be able to do the multi-master capability. So all you have to do in the SDK, for example, is there's a setting here that says use multiple write locations is true, and then the preferred location, Japan, and then the other one is Canada Central. And that's pretty much all you have to do. The rest, the conflict detection and all those things, you can do them on the portal to configure, so I'll show that in a little bit. So it's very simple to be able to just do multi-master capabilities. Recommended, of course, is to try to minimize conflicts, for example, by making sure that records are never exactly the same, right? Like I did in this case. You guys can see in my case, I introduced, if we go back into the Canadian where we can see the record, you guys can see that I made the originating region part of the ID of the record so that it's very unlikely, or unless somebody is manipulating the data, it's very unlikely that I would have any conflicts regardless, right? But the system has conflict resolution mechanisms anyway, and we're going to talk about those now. Okay, So we just saw that multi-master sync. Now let's talk about conflict resolution. So there are three types of conflicts. There's an insert conflict if two regions try to insert a record with the same ID at the same time. There's a replace conflict if two regions try to replace an existing document with different contents at the same time. And there's a delete where, one region actually wants to delete the document and another one is trying to actually update it, right? So what happens? Resolution mechanisms are configured at the container level, okay? So whatever that is, collection, graph, or table. The last write wins is the first resolution mechanism, and it's basically if you specify a field, then it goes by a numerical value. Whatever the numerical value is higher in that field, then that's the winner in terms of a conflict. If you don't specify any custom field is only for the document/SQL API, then the system already will insert its own timestamp. So you don't have to really even have a field for it. In my case, when I built that machine factory client, I did not add anything of the sort. Cosmos just basically inserted its own timestamp into the schema, and that's how it's set to be last write wins. You can also do custom resolution through a JavaScript procedure that will look at the documents, and then you can code your own logic to decide what they should do. And then there's also an asynchronous conflict feed. What that means is that if there is a conflict, then basically Cosmos DB takes no action and it puts the difference of what the conflict was into a feed, basically a queue that you can then consume either on your application or you can review it manually, and then you can decide what you actually want to do in terms of that conflict, how you want to resolve it. Okay. Some things to be aware of in terms of the resolution behavior is that delete always wins. So if something gets deleted, it just gets deleted. If there is a tie in last write wins, so for some reason an exact same timestamp got printed, the system will pick one winner and propagate it. Very unlikely that will happen. Who wins and who loses in last write wins or in a custom procedure is only tracked through the SDK. So if you have a bunch of last write wins conflicts, but the system was able to resolve them all automatically, you don't get any trace of it in the portal. You don't see it at all. Not the portal, no logs, nor anything. The only way to see it is through the SDK. So when you if you try to do an operation and it gets denied because it was basically the victim of a conflict resolution, then the SDK will return you like a specific exception code, and then you can decide what to do with it. The portal does track the conflicts of a conflict feed. So if you say, well, I don't want to have any automatic conflict resolution, just put it in the conflict feed, then those results you can see in the portal. I'll show them to you in a second. And if you set up a custom store proc to do the conflict resolution, and while that store proc is executing, it throws any type of exception, then the system just says, well, I'm just going to put the documents involved in the conflict feed, and then you decide what to do about it. Okay. So last bit here, last demo, we're just going to check here how you configure the conflict resolution, and then I'm going to show you what a conflict feed conflict looks like here in the Azure portal as well. Okay, so let me just jump right back into the portal, and let me find my collection that has a conflict on it. I believe it's this one. Okay, and I can go here to the Data Explorer. Okay, I should have some. I'm pretty sure I do. Let me just do the good old portal refresh. I don't see any. Well, maybe you guys, if we have a couple of minutes, I can actually generate some real quick. Let me see. I have my utility here. And let's see. You can initialize it. This, by the way, is a utility that Microsoft has on GitHub to set up geo-replication routines for Cosmos, and it includes some code to generate conflicts as well. So that's what I'm going to use right now. So right now what it does is just creates a bunch of different Cosmos DB containers. And then once it's done, then I can just run the conflict generation. I just want to show you what the conflict feed looks like. While that's happening though, I'm going to go back and show you the conflict configuration options. Okay. So let me go into Cosmos. All right, and then I'll just show you with this existing one what the conflict options look like. And then we'll go back once that's done. All right, so for example, I have this is the collection that I have that we've been using between Canada and Japan. And you guys can see here, there's an option that says conflicts. Here right now, I don't have any to show for this one in particular. That's where they would show up. But if you go to scale and settings, this is where you have the section of conflict resolution, right? So you can see here, mine says last write wins, and the conflict resolver property, this is the automatic one that Azure will insert into my document if I don't specify a property, right? So that's easy to do. If you don't have one, just let Azure pick it. And if you want to use the custom merge procedure option, then you can do that. And then you have to put here the name of the store procedure that's going to be used for the conflict resolution. Okay, so it's pretty simple to configure. All right, so it looks like that is set up now. Let me just run the conflict generator. And then we'll go back and look for that conflict feed. All right. And again, all you have to do is go check them out on the portal, and then you have to decide what you want to do. Or if you want to write a program that will check the conflicts on the conflict feed and do something dependent on them, then it's up to you, right? You can do that as well. So let's go back here. We should have generated some conflicts now. So if we go where I was before and go to my data explorer. Oh, here they are. So you can see, for example, here I have several collections, and one is set to last writer wins, LWW. Another one is set to be a custom procedure, UDP, and another one is set to do none, right, which basically means to use the conflict feed, as I mentioned before. So there should be something here. Yeah, and then we can see here there's the conflict that was generated. And the portal experience is kind of neat. It just gives you, what the conflict is and what the different values are, right? So we have this document here that is basically saying we have a different region and a different user-defined ID here. So because we said, there's no last writer wins in this collection, it's all don't do any conflict resolution, just put it in the feed, then Azure is basically taking these two documents and saying, hey, look at these two documents. They have the same ID. They're very similar, but it actually has this diff here, right, where we can see that the regions are different, and there's this user-defined ID property that is different as well. And then it will be up to you to decide what you want to do with that info, whether you want to just discard this or whether you want to pick one to be the winner, and then you'll have to insert it on your own though, right? The portal only gives you a read-only view of your conflict feed. Okay. All right. So that's pretty much it for the material, and we are almost at the top of the hour. So I don't know if Jason is around. If not, it doesn't matter. I can check here if we have any questions. It doesn't look like I have any questions right now.
Yeah, no questions at the moment. So
Okay. Well, you know what? Everybody has my contact info as well. So
yep.
if you think about anything after the fact, feel free to add me on Twitter, send me an email, add me on LinkedIn, and get in touch with me. I would love to help you out, give you advice, anything if you're trying to build something on Cosmos for sure. At any time, feel free to reach out as well. And just hopefully this session will give you some curiosity, some interest in this type of, planet scale global solutions that are at everyone's reach now, thanks to technology like this.
All right. Thanks, Warner. And thanks, everyone, for attending. And
Sounds good.
everyone have a great
Everybody,
day. Bye-bye.
until next time, bye.